Hi everyone, welcome to AI Crack channel. This is Akash Hangwar and today we'll be studying permutations and combinations lecture 2. So in this lecture we'll be talking about selections, bundle method and gap method. So let us start our discussion with selections. We have already talked about selections in case of binomial, right? And we defined it by NCR. So basically number of ways of selecting R objects out of n available distinct objects is called as NCR and this is called as selections. Now let's say we have the A, B, C, D, and E. We have these five different objects, distinct objects, right? And now I have to select three out of them. So in case of permutations, I would have done that. If I have to permute, I have to take three objects and make the arrangements. I would have done ABC, ACB, BCA, BAC, CAB, and CBA. So these six cases I would have made, that is nothing but 3 factorial, right? Now if I try to write a formula for NPR, NPR is basically n factorial divided by n minus r factorial. And we know the formula of NCR from binomial, that is n factorial divided by n minus r factorial multiplied by r factorial. Now this additional r factorial is nothing but this only, right? So basically we are choosing r objects over here. We are selecting r objects over here. So this is nothing but 3 factorial or r factorial, right? Now, if I correlate NBR and NCR over here, so that should mean in case of NPR, we are arranging all these things, but in case of selection, we are not arranging them. These six mean one only over here in case of NCR because we are just selecting. In case of permutations, these six were different arrangements. In case of selection, this just means one single selection, right? So basically, we have to divide this entire NPR formula by r factorial. Over here it's 3 factorial, but in case of NPR we will divide this entire formula by r factorial. And if I divide this by r factorial, that would become NCR. So basically NPR divided by r factorial equals to NCR based on the logic and the formula. So that would give us NPR equals to NCR dot r factorial. So this is our main formula. I'll remove this. This is our main formula. NPR equals to NCR dot R factorial. And from now onwards, even if we have to, do the permutations, we'll also be using this format and not this format. Then that would make our life much easier as compared to directly using this format. Okay. Now let's look at one example. In how many ways a team of 4 boys and 4 girls be selected out of 6 boys and 5 girls if a particular boy and a particular girl refuse to work together? So let's say we have 6 boys and 5 girls. So B1, B2, B3, B4, B5, and B6. We have 5 girls: G1, G2, G3, G4, and G5. Now we have to select 4 girls and 4 boys, right? I think this is 9. Okay, yeah, 4 boys and 4 girls. Now there is one particular boy and one particular girl who refuse to work together. Let's say those are B1 and G1. Now we'll have three cases over here. Let's say if B1 is over here, then G1 won't be able to work because they cannot work together. So we'll have to make these selections of girls from these remaining 4 ones. And in case of G1 is there in the team, in that case B1 won't be there. So we'll have to make the selections of boys from these 5. In case both of them are not there, that can also be a case. So in case both of them are not there, then we'll have selections of boys from here and girls from here, excluding both B1 and G1, right? So let's write down our three cases. So let's say B1 is here. So in case of B1 is here, now we are left with 3 seats of boys, and we have 5 boys remaining. So basically we'll fill them in. We'll select 3 boys in 5C3 ways multiplied by. Now, if B1 is working, G1 won't work. So we have just the 4 girls remaining and we have to choose 4 multiplied by 4C4. Now the other case would be we have G1 over here. So if G1 over here is, then B1 cannot work. So we have 5 boys remaining and we have to choose 4 boys. We have to select 4 boys. So basically we'll be getting 5C4 multiplied by, now G1 is already there. We need 4 girls, but we have already selected 1. So basically we need 3 more girls and we have 4 are remaining actually. So multiplied by 4C3. Now the third case, in third case, both B1 and G1 are not there. 1, 2, 3, 4, 5, 6, 7, 8, right? So both B1 and G1 are not there. So we have to make 4 selections from these 5 boys and 4 selections from these 4 girls. So 5C4 multiplied by 4C4, right? Now you have to add all of them and that would be your answer. Lines L1 and L2 are parallel to each other. 3 points are taken on line L1 and 4 points are taken on line L2. How many new straight lines can be drawn passing through these points? Okay. So we have this line L1 and this line is L2. So this is 1 point, 2 point and 3 point and 1, 2, 3 and 4. Let's say this is P1, P2, P3. This is P4, P5, P6 and P7. Now in order to make new straight lines, we have to choose 2 points, right? Now, if I choose P1 and P2, basically points on the same line. If I choose P1 or P2 or P1 or P3 or P1 or P4, then I would be generating the same line which is already there. So we have to make new lines. To make new lines, we'll have to select 1 point from here from L1 and 1 point from here, that is from L2, right? So selecting 1 point from L1, that would mean 3C1 multiplied by selecting 1 point from L2, that would mean 4C1. That would give me 12 as the answer. Now that was the case A. This is B. Now in case of B, how many straight lines can be drawn passing through these points? Now you might think that okay, we have 7 points and now we don't have any kind of a restriction of forming new straight lines. We can form any sort of line. So why not select 2 lines from these 2 points, from these 2 lines? So we have 7 points in total and we have to select 2 points from these 7 available points. And any selection of 2 points, basically if I'll be joining any 2 points out of these 7 points, that would create a line. That seems okay, but once you look in the detail, then you'll see that if I select P1 and P2, then I will form the line L1 only. If I select P1 and P3, then also I'll be forming the line L1 only. If I select P4 and P5, I'll be forming the line L2. If I select P4, P6, then also the same. P4, P7, then also the same. So basically cases are being repeated over here if I do this approach. So basically what I'll be doing 3C1 to 4C1 only. And after that, I'll be adding 2 lines, basically L1 and L2. Because if I choose any 2 points from here, I'll be getting L1 only. If I choose any 2 points over here, I'll be getting L2 only. So plus 2. So that would give me 14 as the answer. Now let's look at this example. Count the number of rectangles in a chessboard. So we'll take a smallest example first and then we'll proceed for the bigger example of chessboard. Right. Let's say this is our some kind of rectangular grid. Okay. Now we have to count the number of rectangles. So I can see this square as a rectangle. I can see this 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 entire box as a rectangle. So basically, one should be knowing that how a rectangle is forming. A rectangle is forming by the intersection of two horizontal and two vertical parallel lines. Right. This is how our rectangle is being formed in any of the grid. So basically we have 1, 2, 3, 4 and 5 vertical lines over here. We have 1, 2, 3, 4 and 5 vertical lines over here. If I select any 2 lines from these vertical lines and if I select any 2 lines from these horizontal lines, I'll be creating a rectangle, right? So basically in this case that would be 5C2 dot 5C2. Similarly, in case of chessboard, we have 8 such rectangles, right? 8 such columns and 8 such rows. So basically, we'll be having 9 lines, 9 horizontal lines and 9 vertical lines. So basically, our answer would be 9C2 dot 9C2, right? So A is the correct answer. Now let us talk about packet bundle and gap method. So this is one method and this is one method. Let's say I have A, B, C, D, E, F. So let's say I have these 6 different entities. Okay, the 6 different entities or objects, whatever you say. Now the condition given over here is we have to arrange these 6 objects in a manner that A, B, C stay together. So basically, if we can have A B C D E F, we can have B A C D E F, or we can have C A B D E F. So no matter whatever is happening, these ABC are staying together. They can interchange their positions among themselves, but they're not moving somewhere else, right? So it can also be like D A B C E F or D B A C F E, something of this sort. So basically ABC are sticking together. They're not moving anywhere else. So that basically means what we can do, we can consider them as one entity. So one packet or one entity or one bundle, whatever you call it. So we can call it as one packet. Now we'll arrange this one packet along these three other remaining objects. So basically in this case, we have four objects to be arranged. So if I try to write down the total number of permutations over here, arrangements over here, I'll be getting 4 factorial multiplied by, they can also arrange themselves. It can be CAB, it can be BAC, it can be any other arrangement, possible arrangement, right? So that would be 4 factorial into 3 factorial. So 4 factorial for 1, 2, 3, 4, and 3 factorial for 1, 2, 3. Okay. Now let us talk about the gap method. So in case of gap method, what happens is, let's say we have a team of few boys and girls. So let's say B1, B2, B3, B4, B5, let's say G1 and G2. So let's say this is a group of few boys and girls. Now the condition given over here is both the girls cannot be together. So we have to arrange this entire team or group in such a manner that both the girls cannot be together. So basically that means there has to be someone in between both G1 and G2, right? Now if someone is going to be between G1 and G2, so what we can do, we can mark the gaps over here and place these G1 and G2 in these gaps. And if I'm placing G1 and G2 in these gaps, then no matter what, they'll always be separated by someone in between them, right? So basically they'll not be together. So this is called the gap method. So in this case, we can arrange these 5 boys in 5 factorial ways. And if we have 5 boys, basically we have 6 gaps. So out of these 6 gaps, we'll be selecting 2 gaps and placing these G1 and G2 in those gaps. So that would be 6C2, and multiplied by, they can also arrange themselves G1, G2 or G2, G1. So 2 factorial. So let's say if we had G3 over here, then in that case, it would have been 6C3 into 3 factorial. And similarly for G4, 6C4 into 4 factorial, right? So this is how a gap method and bundle method works. Now let's look at few examples. A library has 3 VARC, 2 DLR, and 5 mathematics books, which are to be arranged on a shelf. In how many ways can these be arranged such that all books of same subject are together? Considering books of same subject are identical, and books of same subject are also distinct. So let's say we have V1, V2, V3, D1, D2, and M1, M2, M3, M4, M5. So we have these many books available with us, and we have to arrange them in such a manner that all the books of same subject are together. So basically, these are actually packets. So they can move among themselves, but they cannot move outside the box. Okay. So basically, we have 3 major entities, this one and this one and this one. So we can arrange them in 3 factorial ways. Now, in case they are different, so basically this would also arrange in 3 factorial ways inside the box. This would arrange in 2 factorial ways, and this would arrange in 5 factorial ways inside the box. So this is the case when books of the same subject are also distinct. Now, in case books are identical, then it would become VVV, it would become DD, it would become MM, MM, M, and M. So no matter what kind of arrangement you make, that would be same, right? So the answer would be 3 factorial in the first case. Okay. Now let's look at this example. In how many ways the letters of the word imagination be arranged such that both A's are together, both A's, both N's, and all 3 I's are together, all vowels are together. So we have this word imagination, and let's break it down. So we have 3 I's over here. So this one gone, and this one gone. We have one M, we have 2A, 2A's, we have 1G, we have 2N, we have 1T and 1O, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So you just have to cross check all these things to avoid mistakes in the examination. Now the first question is both A's are together. So let's write A, and the remaining words would be I, M, G, N, N, T, O, right? So this is one packet and all the remaining letters are actually free. So they are all single entities and this AA is one single entity. So we have 9 letters over here and this is one. So basically we have 10 overall entities. So we can arrange them in 10 factorial ways. Now we cannot arrange them because both are actually AA. So we cannot arrange them. But we'll have to eliminate the cases of identical ones over here. We have 3 i's over here, 2 n's over here. So divide by 3 factorial and 2 factorial, right? So this is the answer for the first question. Now let's look at the second question. Both A's, both N's, and all 3 I's are together. So AA is one box, I is one box, N is one box, and the remaining is MGTO, right? So basically we have 1, 2, 3, 4, 5, 6, 7. 7 entities, 7 different entities. So 7 factorial. And we don't have to divide by any factorial because we don't have any common elements over here. So this is one different entity. This is one different entity. This is one different, and all these are also different, distinct, right? So basically we don't have to divide over here by anything else. So 7 factorial is the answer. All vowels are together. So you can keep this as homework. Now let's look at this question. In how many ways the letters of the word imagination be arranged such that both A's are separate, no two I's are together, vowels and consonants are alternate, two I's are together but separated from third I. Okay. So again we have the similar case. We have 3 I's. Let's write it from here. 1M, A2 and G1, A2, G1, N2, T1, O1, N2, T1 and O1, right? Now the first question says that both A's are separate. So basically we have I, M, G, N, T, O. So the remaining words are these ones. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We have 10 gaps. And if I want to separate both the A's, then basically I have to fill and the two A's in these gaps only, right? So 10C2, we have to choose two gaps out of these 10 gaps and fill in the A's over here. But since they are identical, so we don't have to do the arrangement over there. And now the arrangement of the remaining letters. So that is 9 factorial divided by, because of this 3 identical letters will be having 3 factorial, and because of these 2 identical letters will be having 2 factorial. So this is an answer for the first question. Now second question is more or less same. No two i's are together. So in this case it was 2 a's. Now the second question is no two i's are together. So basically we have to separate all 3 i's and fill in these gaps. Okay. Now the third one is vowels and consonants are alternate. So we have I, A, and O. These are the vowels, and the consonants are M, G, T, N. Okay. So we have 6 vowels and 5 consonants. Now we have to make consonants and vowels as alternate. So we have 6 vowels and 5 consonants. Okay. So if we start from V vowel, so then we'll have consonant V, C, V, C, V, C, 1, 2, 3, 4, and V, C, and V. So this is how we are going to write it, right? Now if I start from, let's say, C, then we'll be getting V, 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 and C, 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 and C. So in this case, if I'm starting from C, then we have to take 2 vowels together, and that is not possible. So this is not the correct case. The only correct case is this one. So basically, we have to arrange 5 vowels, and we have to arrange 6 vowels, and we have to arrange 5 consonants. So even if you apply the gap method, that would yield the similar answer. But in this case, because the numbers were favorable 6 and 5, so we had to take the manual case. We have to take the manual route. Okay. So to arrange the vowels, what we'll be doing? 6 factorial divided by 3 factorial, 2 factorial. multiplied by for the arrangement of consonants will be having 5 factorial divided by 2 factorial because of this. So this is the answer. Now you can take the fourth question as homework. So today's lecture was till here only, and we have covered the majority of the syllabus of PNC series. We are left with circular permutations, distribution of similar objects, and certain miscellaneous examples. So that would be covered in the tomorrow's lecture. So let's meet tomorrow. Thanks for watching.